Hello there. So I see you're discussing Lab 1, which is perfect because that was my plan for tonight. Now, if there's something else that you want me to go over as well, do not hesitate to ask because, it's kind of fair game. It's not Taco Tuesday, but I guess it's Try Anything Tuesday, all right? But my plan is Lab 1. Okay. Oh, shoot. All right. So I'm just going to jump in and start going through Lab 1. I'll probably repeat a little bit of what we did last Thursday's meet session because I think all we got through the last Thursday was just kind of looking at the description. But questions, pop in there, ask them at any point in time, and hopefully a lot of things will be clarified for you when we get through with this session here. All right. So the Word doc is the scenario, so it kind of outlines for you, try to give you like a real world type of experience with a little bit of humor in there. But there's also some important things to note in there as well. So if we look at this, the person who's hired us to do our programming's name is Jeff Golf. He works at Moorfield as opposed to Moorfield Country Club. You're going to be doing some work for him that object-oriented programming, which is what this whole class is about. So they're talking about creating an app that they'll use on smartphones, which we're not creating any smartphone thing. That's just the scenario they're setting up, all right? So they're going to keep track of their 4 days of competition, 4 rounds of 18 holes each. And they have spotters on the golf course that's going to use their phones to transmit the scores. So kind of like a leaderboard like you would see here. I don't know if you guys follow golf at all. I personally am not a huge golf fan, so I try to avoid it when it's on television, but that doesn't mean that I can't write programs for it as well. Okay. Yes. Well, you and me both. So we'll just struggle through this together here. All right. So we've got some Java code, some handwritten notes. You see there's a prototype called player. So we're going to be simulating a real world entity called a player. So we've been kind of doing this with like dog, right? We've been creating a dog with the breed and the name of the dog, the age of the dog, and the breed of the dog. Well, in this case, we're going to have a player. We're also going to write test cases to help vet out any logic errors we might have in our player class with this player test. And then there's a third class it's all written for you. It's kind of a demo or a driver class, and it just shows you how you can use that class if you were going to be writing a program. And so if you open up BlueJ, part of it is missing off to the side. Let me drag that over. Here it is. So if we open up BlueJ, we can see those three. We see our player class. So this is our user-defined data type class that we're defining. So we're creating this brand new entity called a player that we can then use in a program. This green is going to be our test class. And then this is the actual program here that's going to take advantage. So this you don't need to worry about at all. Right now you can tell it hasn't been compiled because it has the slash lines, and it won't compile cleanly until these are fixed over here. But you don't have to worry about doing anything with it. You can look at it, execute it, do whatever you want to, but nothing is graded on that particular component because it's 100% complete. Okay. There are errors, so your job is to fix the errors, which is what this whole thing is about. This Lab 1 is really all about fixing errors, learning how to use BlueJ in conjunction with WebCat, getting a feel for how the labs work and that sort of thing. Okay. So we've got the purpose of the class. So we have these attributes here, or instance variables. These are going to be our instance variables. Oh, well, that's excellent that you've submitted to WebCat. Even though it probably didn't work or gave you errors or whatever, that's still excellent that you've submitted to WebCat. All right, so we've got these items here. These are our attributes or our instance variables. So like when we were kind of playing around with the dog class or the pet class and during our week 1 or week 2 meet session, we'd come up with the name of the dog, the age of the dog, and the breed of the dog. Well, here they're telling us the name of the player, the number of holes that have been reported for the player. So from 0 to 18 holes have been reported. The total strokes reported for the player. So the player has, done 68 strokes or something, or 42 strokes or whatever based upon those holes, and then their score relative to par. So just in case you aren't familiar at all with golf, there is what's called par, is what they think this is what people should be able to score on this particular hole. So you might have like a par 3 or a par 4 or a par 5 typically. I don't know if they go higher than that or not, but typically a par 3, par 4, or par 5. And if you score that on that particular hole, that's kind of considered a wash. So if it's a par 3, and it takes you 3 strokes to get your ball in the hole, then your score is 0 relative to par, because you don't have any strokes less than par or greater than par. You came in right at par, so you would have 0. If it was a par 3 and took you 4 strokes in, then your score would be 1 relative to par, because you were 1 over par. And if it only took you 2 strokes on a par 3, then you would have a -1 relative to par, because it took you 1 stroke less than par. Okay. All right. There is a constructor for creating an instance of our player, so a constructor that allows us to create an object that has a string parameter naming the player. So it's an explicit constructor that has one explicit parameter inside the parentheses, and it's a string parameter that's the name of our player. There is another, so it should set everything else to 0. So the name of the player will be set equal to the explicit parameter, and then the holes, total strokes, and score relative to par will all be set to 0. Okay. There are set and get methods for all of the different instance variables. So a set and get for the player, a set and get for the holes reported, a set and get for the total strokes, and a set and get relative to par. So what the set and gets are, the set method will change the value of the instance variable. It will set the instance variable to a new value. So a set method would be considered a mutator method. It's mutating or changing the instance variable, the state of the object, right? Where a get is just retrieving or accessing the current value, and so that's an accessor method. So those set methods are mutators, and the get methods are accessor methods. Now there's another method called report score. This one will report a hole number, and then par for the hole, and then the player's score on the hole. So it will say, hole number 12 is a par 3 and the player scored a 4, kind of a thing. Okay. Now that is not going to modify anything. Each column, well, actually it will. Each column report score should appropriately update the instance variables. So if we're passing in whatever values we have to pass in, we're going to be updating different values. So that is actually a mutator method, because it's going to be changing the values of our instance variables. There's also a get percentage completed method, which will tell you how many holes the player's completed. So if there's 18 total holes on the golf course and they've completed 9, they've completed 50%. Okay. And then a two-string method, which is providing us with output, which is telling us, it's going to kind of give us that whole scoreboard kind of a thing. The name, the hole, and then, what their score is relative to par. So Nicholas is -4 after 12 holes, kind of a thing. Okay. All right. So this kind of gives us the laydown of what's going on. So you'll want to keep this handy. You can print it out and highlight these same things I did, or keep it up on your computer, but you want to keep this stuff out handy with you. You're going to be spending your time here in these two methods. Now this is only for lab 1 that we're going to have this particular scenario like we have with the errors and things. In all future labs, you're going to be writing most of the code yourself. Okay, this is not wanting to move. I am stuck. Okay, so we'll wait for my computer to come back and respond to me here. This one just does not want to. Let's open it back up again. There we go. There we go. All right. So what we kind of want to do is look at these two guys side by side. I think it's helpful to look at them side by side. All right. Now, you're looking for things that says your code here or replace, stuff like that. That would be work that you're going to have to do. Okay. Anything that doesn't say that is going to, it has the potential of having a logic error in it, but you're not to at least modify it right off at the beginning. Okay. So if we look over here at this player class, we've got our instance variables at the top, and those were identified for us, remember, here. So name of the player, holes reported, and so on. And so we can see those values here. Notice they're all defined as private, so they're internal to the object only. And then they're defined with their data type, so either string or integer, and then their appropriate variable name. Then we have a constructor here. Okay, and we were told we would have one constructor with an explicit parameter, just one explicit parameter, which is the name of the player. And so the whole point of a constructor, again, is to initialize those instance variables to default values. All right, so we have 4 instance variables, so all 4 of those instance variables will be referenced inside of every constructor that we would have. And in this case, we just have 1. But all 4 will be referenced here, and you always reference your instance variables by appending the keyword this in front. So this dot name, this dot holes played, this dot strokes played, this dot versus par. Okay, so this allows us to reference our instance variables. We have one explicit parameter coming in. So when we call this particular constructor, and we're testing the constructor, so we're calling that constructor and we're passing in one value, one string value, right? Nicholas. This value of Nicholas will get put into this variable in name right here. So now when we call this constructor over here in our test case, it puts the value Nicholas into our variable in name. And then down here, when we refer to in name, we're really referring to the value Nicholas because that's how we called it. Now, I could have called this Compston or Fred or Joe or whatever. It doesn't matter what value I put in this string literal. When I call the constructor, it's going to take whatever value I did, put it into this variable here, this explicit parameter variable, and then I can assign that to my instance variable. So now my name instance variable, this dot name, is going to be equal to whatever value is inside of here. And as I called it over here with Nicholas, it would be equal to the value Nicholas. Okay. The Word document also told us that the other instance variables should be set to a value of 0, initialized to a default value of 0, and that's what we've done here. We've set holes played, strokes played, and versus par all equal to a value of 0. So that initializes our object in our constructor. Now for the test case over here, this is our matching test case. Remember, when you're testing something, the format is always create your object, do any setup work that you need to, call the method that you're testing, and then check to make sure it did what it's supposed to do. Now in this particular case, to create the object, we're actually testing a constructor, which is what creates the object for us. So we need to test the constructor or call the constructor that we're testing. And in this case, there's only one constructor, so we're going to call that one constructor. And it is always class name, object name equals new, and then the name of your constructor, player, and then any explicit parameters. In this case, we have one explicit parameter of data type string. So player is the name of our class. Here we can see right here, player class. We're going to call our object player1. We can call it anything we want to, but temp player, new player, Fred, whatever we want to call it. In this case, it's player1 equals new player Nicholas. Okay, we're passing the string value of Nicholas. Now with a constructor, one thing that you'll do different than when you're testing a regular method is we're going to call this assert not null on our player one object that we just created. And we're saying if this is null, something didn't work. But as long as it's not equal to null, it actually contains a value, then I'm going to assume that my object was correctly created. Okay. And then the last thing I want to do is I want to call my different get methods to retrieve the value of my instance variables and check to make sure they're equal to what I'm expecting. Okay. Now if I call this giving it a name of Nicholas, then when I call my get name method, I would expect it to return me a value of Nicholas. And likewise, if I had changed this and called this with a value of Fred, then when I call my get name method down here, I would expect it to return me a value of Fred, right? Same thing if I called this with the, gave it a name of Smith, then if it works correctly, I would expect it to return me a value of Smith. All right, are you guys following that right there? All right. So for the other ones, the Word document told us that they should be set to default values of 0. So for each one of these methods, the get whole plays, get total strokes, get versus par, I would expect those to return a value of 0, which is what I'm checking right here. Okay, so this would test this constructor. It calls the constructor that I'm testing. It checks to make sure that it actually created an object, that my object is not equal to null. And then I check each one of the instance variables to make sure they contain the value that I'm expecting. Okay, so if all of these work, then we can assume that my test case functioned correctly, or that my constructor is written correctly. Now, if they did not pass, there's there's 5 different places that my error could actually exist. Okay, my error could exist in my constructor. Something over here could not have been set correctly. Maybe instead of setting this hold play to equal to 0, I set it equal to 1. And I'm expecting 0 over here, but it's set it equal to a 1, and so I'm not going to match up. And so I would need to check that. The other place that it could have failed is on any of those get methods, because I'm calling each one get name, get holes played, get total strokes, and get versus par. So if one of those isn't returning me the value that it should be, then that could also be an error. So if this test case would not pass, if it would fail, then I would need to check I'd need to check my constructor and every single one of those get methods to make sure that they're correct. Okay. No, WebCat is not going to care what you choose as your test cases. So you can leave this Nicholas and check Nicholas here, or you can make this Smith and Smith here. It's not going to care. And as a matter of fact, WebCat is going to have a completely different set. It's going to test all these same things, but it's going to use different values. So on the test side, you can name things whatever you want to. Yep. All right, so that takes care of our constructor. And then we get down to these set and gets. So the set method, the whole purpose is to change the value. I'm sorry, this is the get. So the get method, the whole purpose is to return the value of the instance variable. And the set method, the whole purpose is to change the value of the instance variable. So when we have a set and a get for the player name, one of the methods is going to set the name. The set method is going to allow us to change the value of that name. And the get method is going to allow us to return, stop that, sorry guys, to return the value of that name. Okay. So here we have public string, so it's returning a data type string, get name, no explicit parameters, and it's returning this dot name. So it's returning the value of our instance variable for the name. This one is public void. It's not returning anything. It's set name, but it's expecting one explicit parameter of data type string, which is going to be the new name that we're changing. And so it says this dot name equals new name. Okay, so this one returns the value of our instance variable, and this one changes the value of our instance variable to be the value that's passed in. So to test it, we only need to we don't need to have a separate test case, one for the get and one for the set, because we're calling the gets all over the place. We called the get up here, and we'll call the get down here. But this follows that format where call your constructor to create your object. So create your object by calling the constructor. So this time they called it, passing it a value of Soren Stan, right? So again, class name to create an object, it's class name, the name of your object equals new, constructor name, and then your open and closing parentheses with your explicit parameters. So player is still the name of our class. This time they chose player 2 as the object name equals new player, and they passed in Soren Stan. Okay, so this value of Soren Stan would go into our constructor up here. So we would expect our instance variables, when we get this object created, to contain the value Soren Stan and then 0 and 0 and 0. Okay, then they're calling the method that we're testing, which is the setName method. So we're calling it on our object. So player2 dot setName. Okay, and we pass it a value. So this time they're passing Ochoa. Okay, it needs to be different. It cannot be the same value as here. Okay, so we pass Ochoa. So what should happen is this value Ochoa will come over to our setName method. It will get put into our new name explicit parameter variable there. And then down here we set this dot name equal to what's contained in our new name. So our new name contained Ochoa. So now this dot name is set equal to Ochoa. Okay. So if this all worked correctly and I call player2 get name, what value would you expect to have returned if my set name works the way it's supposed to? Ochoa, right. So are you guys seeing a logic error on line 74? Okay, so this test case would not pass, even though our method would work correctly. It's not going to pass because we did not specify the correct value in the test case. So you would want to correct this. And again, you can change this to anything you want to. Like originally you could put, I could put in my last name here, Compston, to create my object. And then maybe I don't like Ochoa because I don't even know who the heck Ochoa is. And so I'm going to go with Jones instead. Then I would want to make sure that down here the value, okay, Woods would be better. Yeah, we can go with Woods. So then if I've changed it to Woods, if I call my get name, I would expect it to return Woods. Okay, and if it didn't, then I have an error somewhere, and my error is either in my set name is not working correctly or my get name is not working correctly. So I would need to look at those two methods to try to figure out what the problem is with those two methods. All right, now this report score one is a little bit challenging, so we have to think about it. Okay, so we've also got over here, we've got the get holes played, the get total strokes, and get versus par. So those are being tested like when we call up here and things. So if one of them were to fail, it could be the constructor or it could be the get method. So you just want to make sure that it's actually returning the correct names of your instance variables. So you'd want to compare each one of those values to the values up here to make sure that they're correct. Okay, so report score. So the whole point of reporting the score is, let me make sure, I almost feel like I need to write this down so I've got it going correctly. So you're going to be passing in the whole, you're passing in the par, and you're passing in the score. Okay, so the whole is so it tells us here, the whole is the number of the whole, par is for the whole, so what the par is for the whole, and then the player's score on the whole. Okay, so they might pass us in like a whole number of 7. They played hole 7. And par for hole 7, so it kind of is helpful to kind of just like write this stuff out. So the whole number is 7, okay? Par for hole 7, let's say it's a 4. Par is 4. But the golfer scored, his score was a 5, okay? Which means he was 1 over par on that particular hole. So what we would expect to have happen when we're all said and done, now remember, what we have up here is the holes played. So the number of holes played, right? The total strokes and where you are relative to par. You could definitely use comments to help you out down here to make sense for you. So the number of holes played, if I have just finished another hole here, so it doesn't matter what hole number this is. This could be hole number 7 or 12 or 14 or 52. How many holes have I finished? Like if I had previously finished 6 holes and now I've just played another hole, how many total holes have I finished? 6 plus 1 or 7 holes, right? So my holes played should now, if I was originally I had 6 holes and now I've played 7 and played 1 more, it should now contain a value of 7 holes. My holes played should be equal to, make sure I'm not confusing myself. What are they doing? Report score. Well, let's walk through the test case here because I think this will help us out. So first in the test case, we create our object, and our player this time is Mickelson. So we're going to report a score. We played hole number 2. So I'm just going to I'm scribbling this on paper. I know you can't see me, but just trust that I'm scribbling this on player. So I played hole 2. It is a par 4, and I scored 5 strokes on it. So I would expect my holes played after I report that score should now have a value of 1, right? Because it's a brand new golfer. No holes have been played yet, so I would have a holes played would contain a value of 1 because I just played hole number 2. The par for that particular hole, for the holes that I played so far, is a 4, so I would expect my par to be equal to 4. And no, strokes played, sorry. Strokes played is my next one. Okay, strokes played. I haven't played any strokes yet, so now it's 5 strokes total that I've played, so that's my strokes. And then for my par relative to, or my score relative to par, it should be a +1, right? Because par is 4, I had 5 strokes, so I'm 1 greater than par. So my score relative to par is a +1. All right, so 1, 5, and a +1. So now I am playing another hole. So now I've played hole number 1. So this time I would expect my holes played to be a value of 2, right? Okay, let me pull up an Excel spreadsheet and see if we can, if I can, because I think, all right, where is my Excel? Seriously, Excel, where are you at? Notepad, File Explorer. Microsoft Excel. Office. Holy moly. Okay, here we go. Okay. So, we have 3 instance variables that we're keeping track of. Holes played. Okay. Total strokes, and then the score relative to par. Okay, and all of these start out with a value of 0. Oops, the very first time, because no holes have been played yet. Okay, so we've got our Mickelson guy here. Okay, no holes have been played yet, right? So we report the first one. Okay, you played hole number 2. Great. I've played 1 hole now. It's par 4, but next is total strokes. You got 5 strokes on that, So I have 5 total strokes. So that would be 0 plus 1 equals 1. Okay, so that's a 1. This would be 0 plus 5 equals 5. And I put in the wrong thing. 0 plus 5 equals 5. So now I've got 5. And then my score relative to par. So I'm going to do my 0, which is my current score of par, plus, and then I need to take my score minus par. Is that right? Yes. Okay. So my score is 5, and my par is 4. So 5 minus 4 is 1. So it equals 1. And now my score relative to par has a grand total of 1. So that gets me through this first one. 1, 5, 1. Sticking with me so far? Okay, so let's move on to the next hole. The next hole is I've played hole number 1. So again, now I've just played, I don't really care what the number of the hole is. I played hole 1. Woohoo! All right, so currently I have a value of 1, so I'm going to do a 1 plus another hole, right, equals 2. I've played a total of 2 holes now. Okay. The par on this hole is a 5. I'm going to skip par for this moment, but I had a total of 3 strokes. So I currently have 5 strokes, so this equals 5 plus 3 equals 8. So I have 8 strokes. Okay. Stop helping me out. Okay. 5 plus 3 equals 8 for a total of strokes. And then I'm going to have par, and the formula is still the same. So right now I have 1. My current score relative to par is 1 plus, and then I had a total of 3 strokes minus par, which is 5. I need to move this over. I'm in the wrong field. Okay, my current value is 1 plus the score, which is 3, minus the par, which is 5. So this is now going to equal -1, because I'm 2 under par in that particular hole, so this would equal a -1. Okay, did you guys follow me on that? Okay, so let's say we had another one. So the first one we played hole 2, and it was what, par 4, and we scored 5 on it. The second one was hole 1, it's a par 5, and we scored 3. Let's say this is now hole 3, and it's a par 3, and we scored 3 as well. So again, for this third hole here, we have a current value of 2. So it's going to be 2 plus 1. We're always just adding 1. You only get 1 for each hole. So now I've played a total of 3 holes, right? Total strokes, so I had 3 strokes. I currently have a value of 8, so it's 8 plus 3, which gives me 11 total strokes. And relative to par, I'm going to take my current value of relative to par, -1, and I'm going to add to it my score minus par. 3 minus 3 is 0, so I actually still end up with a -1. Excel is being so helpful. Yeah, it just wants to help me out here. Let me just stick a quote in here, and then that way it'll stop. There we go. Okay, so we've just worked through 3 different things, and so you guys kind of seeing a pattern of what happens every time I call the report score. What am I doing to the holes played? Every time I call report score, what am I doing? For just holes played. Don't look any further than holes played. I'm adding 1 to holes played. Now when you're adding, you have a couple choices. We can say like a variable 1 equals variable 1 plus 1, right? So this is one way. Let me make this bigger. Okay, I want to make this bigger. There we go. So this is one way you can add to something, is whatever your variable name is equals your variable name plus 1. So this gives you a running total. So we're adding 1 to it. Or you can use what's called a shortcut, an increment or a decrement, and you can do var1 plus plus. Okay, and this just said these two statements are exactly the same. They accomplish the exact same thing. All right. So var1 equals var1 plus 1 just says take the current contents, take what is currently in my variable 1 variable, and add 1 to it. And the var1 plus plus says the same thing. Take what I've currently got in this variable and add 1 to it. Is one better than the other? Absolutely not. One just has less characters than the other, but both of these two statements accomplish the exact same thing. All right. It's your choice what you want to use when you're doing something like that. If this makes perfect sense to you, but this is confusing, then don't use this, right? Stick with this one right here. Okay. Well, and if that makes perfect sense to you, then definitely go with that increment. You know, it's like right now at this point in the course, you don't have to worry about being fancy or what you're doing. The whole goal is to understand, right? And so if the increment, if you're like, okay, that makes perfect sense to me, then definitely use increment. If it doesn't, but this makes sense to you, then use this, because they both do the same thing. So it doesn't matter. The whole point, nope, it doesn't matter to WebCat either. Absolutely not. So either one works. All right, so that's for holes played. That's the whole point of what we're doing with holes played. So total strokes. What are we doing each time with total strokes? Every single time. We're adding to it the new stroke. So in this case, rather than just adding 1 to it, which is what we're doing with the total holes, it would be var2 equals, and there's no shortcut here, okay, equals var2 plus, and then you've got your explicit parameter, right? So in our, oops, let's see, where did you go, Blue Jay? In here, we've got it coming in as score, right? So our explicit parameter score contains our score. So you'll have to add to whatever your thing is the new value. Okay, so whatever that explicit parameter is. Okay, so you'll just, and I'm intentionally giving you a little bit of work, right, by not giving you the names of the variables, but hopefully you will replace your instance variables in here for these and the name of the explicit parameter here. So that's what you're doing there. Now if we look relative to par, what are we doing every single time for this relative to par? Yes, we're adding the score minus par to what we currently have in there. So again, this one would be var3 equals var3 plus, and then it would be whatever the name of those explicit parameters are, right? Score minus par, okay, or whatever. I don't, you know, that might be the name of them, it might not be, but this is what you're going to do. Oops, var3 right in there. Okay, so this is what's happening every single time. So as far as your test cases, you know, we know what should be here, and then we're reporting another score, so you're going to have to fill in these values here. Okay, and so we just walk through how you would do that. So you're going to need to change these values here. And then when you compile this, you're going to have to test it and see, am I getting what I'm expecting? Your test cases will all pass. And if they don't pass, then maybe something over here isn't correct. Okay, and it looks like there's quite a few things over here that aren't correct. So then you would need to come over here and fix this until which point as your test cases pass. And if you can never get to a point where they pass, then, you know, double check here. Like, did I really specify, you know, go back over here and make sure you did the test cases. But the key thing is on these test cases, by working this stuff out by hand, here we know what it should do, right? And we know how this should look. So now it's easier to kind of go over to the code side and figure that out. Okay, so that's report score, and then we've got percentage completed method down here. So again, remember when you're testing these, this exact same format. Create the object, do any setup work, call the method that you're testing, and then check and make sure it worked. So here we're creating our object. This time it's Sorenstam again. We're calling a bunch of different scores, so we need to actually figure this out. I think this is correct for you. But anyway, the percentage holes completed, so they've completed 3 holes. This is an 18-hole golf course. So 3 holes equals 3 divided by 18 is 16.667%. Okay, so this would be correct. So here, you have to manually figure it out to know, but 16.66, you call the get percent completed and it'll compare it. If it passes, cool, and if not, then you need to check it. So over here, we would need to check this to say, is this correctly computing if it doesn't come out. Now, it does give you some suggestions here. Spend a few minutes reading section 4.2.3 integer division. So let me tell you about integer division in Java. So Java has regular division, integer division, and modulus division. So regular division, if we have 3, let's do 10 divided by 3, then, stop being so helpful, 10 divided by 3, then we would expect that to look like this, right? 3.333. However, in Java, it says if you are dividing 2 integer numbers by themselves, then I'm only going to give you an integer result. So 10 divided by 3, so this would be double division, would be this result. But if it's integer division, your answer is going to be 3 with no decimal places. So because 10 and 3 are both whole numbers, they're both integers, Java will only give you the result of 3. Okay? If I want it to give me the double division with the decimal places, then I need to make one or the other of these a double number. So 10.0 divided by 3, 10.0 is a double number. That's going to give me this result. Or if I have a 3.0, 3.0 is a double number, and that will give me this result. But with both of these just being whole numbers like this will be my result right here, and I lose precision. I lose my decimal places at the end. The third type of division is the modulus, which says the answer for the modulus will be a 1. The modulus says just give me the remainder. Don't give me the division portion of it, just give me the remainder. So these two are both represented by a single slash. It is not letting me type that in. The modulus is a percent symbol. Okay. So these are both a slash, but you have to look at the data types of the variables that you're dividing to know if you're going to end up with double or integer. The modulus is a percent, and it always gives you the remainder. So what they're trying to tell you here is if this dot holes played is defined as an integer, and this value here, which oddly does not look correct, is also defined as an integer, your result here is going to be an integer. And so you're not going to get 16.66. You're going to get 0 or 0. You'll end up with 0 every single time. The reason you'll end up with 0 is because 3 divided by 17, or which that should not be 17, you guys all know that, right? Because if we went here, 3 divided by 18 was 0.666, right? And since it only gives you the whole number, it's going to give me a 0. and then I multiply that by 100, and 100 times 0 is 0. All right? So you're always going to get 0 with this particular calculation, so you need to convert one or the other to be a double value, and the easiest one will be the literal that you've got here, and just put a 0.0 on it, and now it becomes a double value and you get double division. But that is not the correct number. All right, and then we have the toString here, and so you are supposed to replace this statement. So what you've got up here is we've got Mickelson. All right, so the output is supposed to be, let's go back to the Word document. Nicholas is -4 after 12 holes, or whatever it is. So we've got Mickelson is -1 relative to par after so many holes. So you're going to need to replace this with player1.toString contains, and then you're going to want to put in there after however many holes are played here, and it looks like they're reporting the score for 3 holes. So it would be after 3 holes is what you'll put in this statement here. Okay? So what you're going to do is the first time through, so that gives you kind of an understanding of how all this stuff works, or hopefully it gives you an understanding as to how everything works, right? So what you're going to do is you're going to compile. Nothing over here says that you needed to do anything, right? So you're going to compile it, and it's going to tell you, oh, I can't find the variable par. Well, it's not called par with 2 R's, it's called par with 1 R. So you're going to fix that, and then you're going to compile it again, and it's going to identify all these syntax errors for you, and you're going to fix all the syntax errors, okay? And eventually it will compile cleanly. Yes, you can paste code. Be careful pasting code. Like, are you thinking you just wanted to copy this right here and then paste it down there? Oh, do you want to paste it in here? Is that what you're talking about? In the chat session? Sure. Yep, go right ahead. So now you're going to work through here. Every time it identifies for you a syntax error, you're going to fix it and compile it until eventually it compiles clean. You're going to need to come in here, and anywhere it says replace, put those statements in here and then compile this until it compiles clean. And then you're going to, once they both compiled clean, you're going to right click and do a test all, and it'll run through all of your test cases. Anything that comes up in red, you're going to need to investigate and fix and work. Okay, so I'm going to copy this just so I can make it more readable. All right, let me go into Notepad++. I had that up and I closed it down apparently. Cancel. Okay. And what error message? Oh, it's failing. Well, are all of your other test cases passing? So take a look at your toString down here at the bottom. So it is coming in and saying player name space is space plus this dot versus par relative to par. So is, whatever it is, relative to par, holes played, space holes. So you have after 3 holes, but that is not what the toString is actually printing out. It's hard to, I want to kind of get these so you can see them at the same time. It's putting out this whole state plus holes. And you've got after 3 holes. This has after 3, space holes. So that should work. 2 par after space. So, and all of your other test cases are passing? Let me go to test case. All right, we've got 3 holes. Strokes, 3 plus 4 plus 5, 9, 12. 12 total strokes. Okay, we've got par, 5, 4. Okay, the first time it's 5, so we have a -2 for par for the first hole. Next time is a wash. The next time we're over by 1, so it's -1 relative to par. Mickelson is relative to par. Two string dot contains after 3 holes. Okay. So what I want you to do, comment out this last assert statement and then run your test cases and see if this thing passes. Yeah, nothing is more joyous than programming, that's for sure. Finding a bug like this. All right, so can you comment that out and compile it and see if if this test case passes? It's not passing? All right, so comment out this line here so that all you have is this first statement. And does it pass? Okay, so our problem's got to be here. We do know it's -1. So if I'm looking at this, it should say Mickelson space is space -1 space relative space to space par. So it looks like that should be relative to par after. So the question is, what is it trying to give you? So here's what I'm going to have you do. And I don't want to, I can't go through and fix all this stuff. So what you can do is you can actually go into your test case right here. It's like none of these are really good. Compile this guy over here, because this is our program, right? And run him and see what output he gets. Because it's printing out the 2 strings here. Okay. I'm going to open up the All right, so this is the solution here. And so if I run this guy here, I get Nicholson is 0 relative to par after 0 holes. Then Nicholson is -1 relative to par after 3 holes. Sorenstam is -2 relative to par after 3 holes. And so this is kind of what you're getting right there, right? So I just wanted to check the wordage. Nicklaus is -1 relative to par after 3 holes. It's -1 relative to par after 3 holes, which should be after 3 holes. So I'm just checking for spaces, because what happens is with this assert true, this contains, it is exactly, yeah, you have to have the exact spaces and everything. And so that's where I'm trying to check to see, is there an extra space somewhere? Because it's this statement right here that's not compiling, right? Because if you put this one in, it doesn't compile. What if you take these 2 spaces out on the front and the end of it? Will it compile then? Still not compiling. All right. All right, so what I'm going to do is I'm going to stop the recording. We're at 9:30 anyway. I'm not leaving you guys. I'm just stopping the recording because I'm going to open up the solution, and I don't want that to be recorded.